In our today's class, we are going to discuss about hypothesis and its testing. Okay. Anyway, we are not going to complete the whole process because level of significance and the testing, different tests that we use when we are taking up hypothesis for our research study, that we will take to our next class. This is our introductory class where we will be discussing about what is hypothesis, how do we formulate a hypothesis, what are the factors which we have to remember when we go with formulating the hypothesis, and a preliminary testing part, like we talk about the null hypothesis, alternative hypothesis. That's what we have planned for our today's class. So as you can see in the slide which is shared with you, the first part is we are trying to define hypothesis. We had already had some discussions about hypothesis when we were planning and preparing our proposal. So in that backdrop, we know that it is a formal question that needs to be resolved, or it can be a tentative assumption. It can be an expectation of the researcher regarding a particular area under study. So that is a general definition of the term called hypothesis. So it's just a formal question, which maybe the researcher has got it by reading through different literatures or experiencing that particular situation, or maybe from the respondents. There is a question in his mind which he wants to get either an answer or he wants to solve it. You want to solve that problem. So that is actually the general framework of hypothesis. But when we actually go into the formulation of hypothesis for a serious research study, the second one, you really have to understand the second part which I have put in bold. That is, hypothesis is a proposition or a set of propositions, okay, set forth as an explanation for the occurrence of some specified group of phenomenon, either asserted merely as a provisional conjecture to guide some investigation. So that's a keyword, to guide some investigation, or accepted as highly probable in the light of established facts. So it can be a proposition that which is based on some kind of occurrence. Okay, the proposition is based on some kind of occurrence based on the previous experience of the researcher, or it can be based on the logical, as the researcher thinks, okay, this is the right thing that could happen when we go for some kind of explanation to the fact. Okay, and it is the probability is very high with respect to this kind of proposition. So there could be many types of assumptions, many probabilities which you can see in front of you when you really go for selection of a research topic. But a researcher, when he is seriously engaged in a research activity, he will be picking a set of propositions, or maybe one or two propositions from among all the propositions which might be reflecting the actual condition. That selection can be based on his experience, or it can be based on the facts being shared by the particular group of the respective population, or it can be in the light of other established facts like related area. In a situation like this, when it happened in some other area which is more or less similar to this particular condition, yes, this was the condition, or these were the probable suggestion, these were the probable solutions. So those are the probabilities which led to the selection of proposition. So it is not just a formal question. Here, when we are really going with research, actual research, it will be a serious assumption, serious proposition. Yes, this is what the researcher is saying. Maybe, for example, if I say that, yes, when in our yesterday's example, we were talking about after-sales service having a positive impact on customer satisfaction. So this can be a serious proposition, like after-sales service is having a significant impact on the level of customer satisfaction. This is a proposition that is made by the researcher for testing. He's validating. Then how did he come to this proposition? Maybe based on the established facts, maybe based on previous studies, maybe based on some conditions that were prevailing in that population or in that sample or in that group of study. So that's why we say that it is not just an assumption. In a serious research, a hypothesis becomes a proposition, a proposed outcome, an expected outcome, or the most possible outcome. So that's what we call as hypothesis. And then when we are talking about the characteristics of hypothesis, basically, if I summarize all these points into one point, hypothesis should be simple, should be specific, should be capable of testing. I'm just summarizing all the points which I put in different boxes. It should be simple, it should be specific, it should be possible of being tested. Why being tested? In order to arrive at a conclusion. So these are the basic characteristics or features that should be there when we are formulating an hypothesis for our study. So that's why I put in different boxes, different aspects, which are very much related with the 3 points which I said in the beginning. Simple, precise, very specific, and it should be possible of being tested in order to arrive at some conclusion. So now I take one by one. The first is clear and specific, clear and precise. Clear and precise means it is very much related to our yesterday's concept. A researcher should be able to identify the variables when we are setting the hypothesis. If I'm saying that, yes, after sales service having an impact on customer satisfaction. So my 2 variables involved in my study are after sales service as well as my customer satisfaction. Right. Somebody's trying to enter. Yeah. Okay. So when I'm talking about this clear and precise, what you have to remember in your mind is, am I able to identify my variables clearly? If I'm able to identify my variables clearly, am I in a position to establish a relationship between them? If I say that I have identified many variables, but I don't know how are they related. If I cannot identify some kind of relationship between these variables, no, I'm not on the right track. So that's why I should be able to clearly identify which are the variables I'm going to establish into a relationship, which are the ones I'm going to specify in my study for me to conduct a test and examine whether that relationship is an established one. So that's why it is our hypothesis should be very clear, in the sense my variables should be clearly identified. And once I've identified the variables, I should be in a position to establish the relationship between them. Maybe cause and effect. Price is having an effect on demand, right? Or price is having an effect on customer satisfaction. I'm saying maybe I can establish the relationship into a better way. I can say an increase in price can cause a decrease in demand. I've specified the direction of the movement of my relationship. Increase in price is going to result in a decrease in demand. So I specified that relationship a little more clearly. So that's what we mean by clear and specific, and should state the relationship between variables. In some cases, some of my students approach me with many variables and say that, okay, this is it, what we want to include in our hypothesis. But unfortunately, what is happening over there is they are not able to relate these variables to each other. If you cannot relate 2 variables to each other, there is no possibility of testing. You cannot test it, you cannot validate it, and you cannot come to some meaningful conclusions. That's why it has always been said that your variable should have some kind of relationship, and it is that relationship what we test through the hypothesis testing. We are testing whether there is an establishment of that relationship, whether there is an established relationship between these 2 variables. So That's what we say, that we should identify the variables, we should establish the relationship between these variables, and to be on a safe, it's not mandatory. Maybe in scientific research, it may not happen often, but when we are talking about a relationship, establishment of a relationship, it should be consistent with most of the known facts. There are exceptions, okay? There are exceptions, but generally, when we are setting relationship, that relationship should not be, no, it should be contradicting the existing facts. It should never contradict, or it should not be contradictory to the understanding of the general public. If I'm saying that how much ever I go with increasing the price on daily consumables, it is not going to affect the demand of that product. People will buy it. Demand has no relationship with price. People may be little doubtful to believe you, because that is little against the established theory about demand and price. Right. So the same way, when a researcher is trying to understand, see, when a researcher is trying to say that advertising has no impact on sales promotion, it will be pretty difficult for him to establish this theory, because it is totally against what is being prevailing in the market, in the field. So that's why we say that normal. But in certain cases, yes, there can be a revision in the existing theory because of the changes in the external environment, because of the changes in the practices, or because of the regulation, newly introduced regulation. There can be a change. There can be, but generally a researcher should be aware with the existing theories around the particular fact under study, around the particular area under study, and it should be consistent with most of the known facts. If it is totally against what has been established till now, maybe a researcher will find it very difficult to test it and come to some meaningful conclusion. So that is why it has been said that the researcher should be aware about the base studies, the basic works that has been conducted in that area, at least during the recent period. Right. And then, as I said in the beginning, capable of being tested. If the variables are not quantitatively expressive, or it cannot be expressed in quantitative terms, it may not be possible for testing it. Right. Yesterday we discussed about qualitative facts being expressed into quantitative terms by giving value. We are giving value to make it to express that in quantitative terms. Suppose if our variable is in a position where it is not able to identify that in measurable terms, if our variables are not able to be, or it cannot be identified in a measurable terms, then it will not be leading to a hypothesis that can be tested. A researcher should avoid such possibilities. Suppose if I say that employee motivation, I want to study the relationship between employee motivation and the remuneration package, or I want to look up the relationship between the bonus, the monetary benefits within a company, and employee motivation. If I'm not, as a researcher, if I'm not able to bring these two terms into quantitative one, into a measurable one, the financial, or as I say, monetary benefits and the motivation, both of these variables into a measurable term, it is better that I should not go for it. If I'm not in a position to bring that into a measurable terms, I should not bring that as my hypothesis, because it's not possible to test it, come to a conclusion. So if I do not have that provision, people will not believe the results of my study. They will not agree to the results of my study, or it might be pretty difficult for me to establish that as a theory or a model. So that's why it is being said, variables identified should be possible to bring that into a quantitative terms, and it should be possible, the relationship what we have established should be possible to undergo different, or it should be capable of being tested using different statistical tools, right? And limited, it has another meaning also, but in this what we have meant is the scope of hypothesis should be limited to a point where it is possible for us to test and evaluate. If I'm trying to conduct a research for 6 months, and if I'm taking the data maybe for 20-25 years and I'm trying to test it, maybe it is beyond my scope, me being a single researcher, being engaged in this research study. So that's why the scope of my research, that from the beginning we have been telling, it should be dependent on the resources, it should be dependent on the time available to me. So I know that I have to test and come to a conclusion regarding the relationship which I've studied. So always I should limit the scope of my hypothesis to a point where it is possible for me to do a fair testing, to undertake a fair testing of the available data. I should not go beyond a point where I'm not in a position to validate the result, evaluate the result, and come to a conclusion. And that is another thing is, I have heard about extensive studies which is being conducted for more than 20 years. I recently heard about the psychological impact of government policies on citizen. So a country, a developed country like US is undertaking such a study for the last 20 years in a particular group, identified group. They are conducting the study over the years, and every regular intervals they are publishing the result, like what is the impact it is going to create. They have a framework, a set of framework. They have been conducting that for the last 20 years. That's a long period for an ordinary research, right? So that is why we say that the testing period should be amenable, should be reasonable within the within the possibilities of the researcher. If the researcher is extending, if it is beyond the control period of a researcher, we may not be able to arrive into a correct conclusion. So that is why it has been said that the test period should be within the amenable period, or within the boundary possible time. The time frame should be fixed at the beginning itself. When we are setting the hypothesis, we should be in a position to know how many months I'm going to observe the selected test group, and how many months I'm going to observe it, and then give the training. Suppose if I'm trying to understand the impact of training on a selected group, maybe group of student community, I should specify, okay, how many days I'm going to offer this training, and how many days I'm going to observe the selected group, and what time it will take for me to come to a conclusion. I should have a framework at the beginning itself. Then only I would be able to complete my study in the right time. So that's why it has been said that hypothesis, the testing period should be fixed well in advance. It should be a feasible time for the researcher to arrive at conclusions. And along with that, the hypothesis become useful only when it is empirically tested. It has been tested by conducting different statistical tools, or by using different statistical tools. So that's why every hypothesis which we said should have some kind of empirical evidence, research-based evidence to prove or disapprove its existence. Right. So these are the basic features of hypothesis when we are planning it for a research. It might be a little different from a scientific research. We are talking in the context of a social science research. So first and foremost, I again summarize that into three things. One is it should be simple, it should be specific, it should be possible to test and validate the condition. All right, so that's why we say that we should be able to identify the variables very clearly for our study. And if you have identified the variables, we should be in a position to establish the relationship between them whether a positive or negative. And if we are not sure about the direction of the relationship, that's okay. We can say that there is a significant relationship, but we should be able to establish the relationship between variables. And when we are setting the relationship, it is better if we can update itself and keep it aligned with the most of the known facts. It should not be totally contradictory to all the established facts till now, because in that case, the researcher might find it very difficult to proceed with the study. And the next thing is, since the models or hypothesis testing models will be accepted only if it is validated with different empirical evidence. So that's why we say that the hypothesis model or the variables identified and the relationship should be prone to different tests, should be possible to undertake different tests using variety of statistical tools, so which should be capable of being tested, and it should be possible to arrive at conclusion within a stipulated time. So these are the features, general features, which you have to remember when we go with setting a hypothesis. Now you have a hypothesis in your hand which you have prepared for your proposal. Please validate your hypothesis with the extra knowledge which we have discussed in our today's class. Please validate it. Just check whether it satisfies all these qualities which we have mentioned just now, right? Now, these are the most important things which you have to understand when we go with testing of hypothesis. Please listen to me very carefully. When we talk about hypothesis testing, there are two things that will definitely come into our review. One is null hypothesis, which is denominated as H0. Second is alternative hypothesis, which is denominated as H1. So every time a researcher, when he is setting a hypothesis, it will be either accepting a null hypothesis, that is H0, or the researcher will be in a position to will not be in a position to accept the null hypothesis. Indirectly, he is accepting the alternative hypothesis. I repeat, whenever a researcher is planning with a hypothesis testing, the results will either accept the null hypothesis or it will reject the null hypothesis, leading to accepting the alternative hypothesis. So as I said in the beginning, null hypothesis is denominated by H0, alternative hypothesis is denominated by H1. Okay, so this is the kind of relationship which we will be testing, no matter whether that is a study with respect to two variables which you have identified from maybe from a psychological angle, or maybe from a marketing management angle, or it can be also from a financial angle. But always the key term which you have to remember is there will be accepting or rejection of null hypothesis. That will be happening every time when we go with testing of hypothesis. Now, another thing which you have to understand is mu and mu naught. Population mean is called as mu and hypothesized mean is mu naught, which again population mean, it is very difficult to get if we are going with social science which include the entire population of Kerala. For some aspect, maybe with respect to, in certain cases we will have average, but if I'm talking about the average in the preference of people of Kerala with respect to some specified financial products, maybe I'm looking at insurance. It is very difficult for me to bring a population mean for factors like that, which are not readily available to me. It is very difficult. But hypothesized mean is nothing but it is the sample mean, which I take from my sample. It is actually the average of average value which I got from my selected sample for my study. Okay, now we are going with the first steps or first few stages in the testing procedure. Now listen to me very carefully. Generally, these are in general terms. As we go in our tomorrow's class, we will go with different types of tests that are possible through hypothesis testing. The first one which we are going with is the testing. In the first general test is here assumption is population mean is equal to hypothesized mean, which means population, there is no difference between the mean of the population and the sample and the selected sample. It is one and the same. So that's our null hypothesis. So our H note is population mean is equal to sample mean. I have just put a value, maybe 100. Both are 100. That's our null hypothesis. And when we are testing it, we are just finding out the mean of the population as well as the mean of the sample. Say, for example, for me, if I want to know what is the average percentage of students, okay, average mark percentage of students in our college, in St. Paul's College, I had put that as maybe I call that as 80. Okay, 80 marks, 80%. So what I did is my population mean is 80%, and I assume that there is no the whole. I took maybe when we are talking about 1,600 students, I'm just taking up the marks of 1,600 students. I'm dividing it and finding out the mean. That's what I call as population mean. Total marks divided by number of students. That's what I call as population mean. I took that, I got it is 80 upon 100. Okay, that is 80%. And then I believe that this will happen with respect to this mean is same for the students from first PG. Okay, I believe, and it is my belief, it is my proposition, okay, based on established practice, because normally PG students come with a high mark. So I believe that they are also having a minimum of the mean, the average will become 80 marks upon 100. So that is my population mean, and my sample mean is equal to 80 marks upon 100. That's my assumption. I'm going to test it. Okay. And once I'm testing, what I will do is my population, I took the whole population, the whole of the students in the college. Okay. And for my sample, I took PG first year students. I collected all your marks. I divided by 30, total of your number. I divided it by 30. And if I get the answer as 80, I accept my null hypothesis. Why? I said population mean is equal to sample mean is equal to 80 marks. I accept it. But when I'm evaluating, I found that yes, first year PG come with higher marks. So the average of these students are pretty higher than the average of the entire institution. Maybe I got the answer as 90 marks. Okay, I got the answer as 90 marks. In that case, I will be rejecting my null hypothesis. I'm not in a position to accept my null hypothesis because my sample mean is different from my population mean. My sample mean is having 80 marks. I mean, my population mean is having 80 marks and my sample mean is having 90 marks. So I am not in a position to accept my null hypothesis. In the sense, indirectly, I'm accepting my alternative hypothesis. Okay, I hope you got the scenario. So when I'm saying that there is no difference between the mark of the average student of the institution and the average mark scored by PG student, and if I get the answer, if I get both are same, if both mean 80 marks, my condition is I accept the null hypothesis. But if that is not the case, I'm going to reject the null hypothesis and I will go with accepting my alternative hypothesis. In that case, we will write the researcher is in a position of not accepting the null hypothesis, H naught, So the researcher will be accepting the alternative hypothesis, and there can be two possibilities, I mean three possibilities for the alternative hypothesis. One is a common possibility. Why? Sample, the population mean is not equal to sample mean. Yes, average mark for the population is 80, average mark for PG student is 90, student is 90. So it is not, the average population mean is not equal to sample mean. I can say that, or I can say that population mean is greater than sample mean. In this case, it is not that. In this case, sample, the alternative hypothesis is that population mean is less than the 100, less than what I've said. Population mean is here, that is the case, right? Here, that is the case where when we are considering with the average of PG students, we got 90 marks and the average mark for the entire college is just 80. Population mean is less. Right. So these are the three possibilities that can happen when we are accepting the alternative hypothesis. In some cases, we can understand that. In this case, we can understand the direction very clearly. But in certain cases, we may not be able to understand the direction very clearly. In that case, we will say we reject the null hypothesis since it has been found out that there is difference between the population mean and the sample mean. When we are rejecting the null hypothesis, what is happening is automatically we are accepting the alternative hypothesis. So I repeat once again, because this is very important for us. The test is, this is the basic test. Okay, we have different types of tests. The basic test is, in a null hypothesis, we say that there is no difference between the population mean and the hypothesized mean. Okay, and if that is the case, if we arrive after the test, if we arrive into a condition where there is no difference between the population mean and hypothesized mean, we accept the null hypothesis and reject the alternative hypothesis. But after the test, if we find out that there is a significant difference between the population mean and the hypothesized mean, the researcher is in a position to reject the null hypothesis. It means indirectly we are accepting the alternative hypothesis. Now that I said, there can be three possibilities which has resulted in this difference, in this rejection. The first one is a general thing. The population mean is not equal to hypothesized mean. The second one can be population mean is greater than the hypothesized mean. Or the third one is population mean is lesser than the hypothesized mean. These are the three possible alternative conditions which we will arrive at when we conduct different types of tests. There are different types of tests which we go, maybe you are going to learn that in a few classes in your, I think it is in your semester 2, you are going to learn with the testing of hypothesis in your statistics paper. Now, preliminary thing you will learn it here in this in our first semester as part of hypothesis testing, but the detailed study you will have in your semester 2 in your statistic paper. Now, the second part which I would be discussing in today's class is type 1 error and type 2 errors. Okay, type 1 errors and type 2 errors. When we are talking about accepting and rejecting null hypothesis, it happens with the case of either acceptance or rejection of null hypothesis. Now listen to me. When I am rejecting the null hypothesis, okay, when I am rejecting H0 when it is true, that is called as the first one, type 1 error. I'm rejecting the null hypothesis when it is true. Say, for example, in our previous example, there was no difference which was exhibited between the population mean and the sample mean, but I rejected it. Knowingly or unknowingly, I rejected it, accepting the alternative hypothesis, stating that there is difference between the population mean and the sample mean or hypothesized mean. That's what we call as type 1 error. And type 2 error is just the opposite, accepting H naught when it is not true. That is, in our previous example, there was difference between the hypothesized mean and the sample mean, but I accepted knowingly or unknowingly. That will be called as type 2 errors. I repeat, rejecting the hypothesis when it is true is called as type 1 error. And accepting the null hypothesis when it is not true is called as type 2 error. So these are the two types of errors that can happen when we are conducting testing of hypothesis. Either we will accept the hypothesis when it is not correct, okay, and that is what we call as type 2 errors. Or there is a possibility that maybe by statistical error or some kind of mistakes, we are rejecting the null hypothesis when it was actually true. And that is what we call as type 1 error. Right. So this is all which we will be discussing in our today's class. I just summarize. We started with what is a hypothesis. It is a proposition which a researcher would be. It can be one or it can be a set of propositions that a researcher would be making when we starting with the research process too, and it will give him or her a direction for his or her research. And the proposition would be set based on some established facts or maybe non-facts or based on the references made by the previous studies. In any case, this is basically for controlling the movement or activities within the planned research work. Okay, and the second thing what we learned in our today's class is what are the features of a good hypothesis. I summarized all the features which we discussed into 3 points. First one is it should be simple. It should be simple to understand. When you make it as complicated as possible, it will be very difficult for us to undertake different tests. It will be a Herculean task to arrive at the right type of test. That's why it's been said it should be clear, it should be precise. In the sense, we should be able to identify the variables, quantify the variables, and establish the relationship between the variables. That's what we say as it should be specific. We should establish the relationship between the variables in the right way, based on the established facts, based on the non-facts, or maybe based on the previous studies which been conducted in the similar area, right? And the last feature is it should be possible to test it, because a model, a hypothesis will be accepted only when it has some kind of empirical evidence. So in order to bring some kind of empirical evidence to the model proposed by the researcher, there should be possibility to test the model, to evaluate, to validate that with using different statistical tools. So these are the basic features which we said. Then we talked about null and alternative hypothesis, and also type 1 and type 2 errors. Null hypothesis generally establish a relationship between two variables, and when we are trying to reject null hypothesis, indirectly we are accepting the alternative hypothesis. Null hypothesis is it is expressed as H naught. Alternative hypothesis is generally expressed as H1. And when we are looking up the research studies, normally a researcher would be quoting the alternative hypothesis, because null is understood. Once you know what is the alternative hypothesis, the null hypothesis, it is very easy to establish that into a statement. It's very easy. So in a research study, we generally go with stating the alternative hypothesis. That's what actually the researcher is trying to accept or reject. Right. And again, we talked about type 1 error and type 2 errors. In case of type 1 error, it happens when we reject the null hypothesis when it is true, and type 2 error occurs when we are accepting the null hypothesis when it is not true. It can be because of some statistical errors, or it can be because of lack of knowledge of the researcher, or it can be because of error of commission by mistake, right? But this is the case. Okay.